So I've got 4 examples here that say use power series operations. We are allowed to add 2 series together. We can multiply, things like that. It says define Taylor series at x equals 0. So again, that's the a value being 0 for the following functions. So the first one here, we have x e to the x. So we're going to write this as a series. From the first page of the notes, I said that e to the x is the series from n equals 0 to infinity of x to the n over n factorial. So I can rewrite this as x times that series. So if I take the x inside that sigma, I now have x times x to the nth. And I can write that out here just to show you what I mean. So we end up with the series here of x to the n plus first power over n factorial. And again, if you wanted to write out the first few terms of it, in this case, you'd have x plus x squared plus 1/2 x cubed, and so on. The second example, we have x squared over 2 minus 1 plus cosine x. Well, cosine x, it's actually at the top of the page, that can be represented as a series, and when you write it out, you've got 1 minus x squared over 2 factorial, which is just 2, plus x to the 4th over 4 factorial, minus x to the 6th over 6 factorial, and so on. Well, the x squared over 2 minus 1 is going to wipe out the first 2 terms there of that series because they're just opposites of each other. So all this is gone, so we're just left with this series, but now instead of starting at n equals 0, we have the series that starts at n equals 2. So I'm going to just, let me scroll back up here. So we just have this cosine series. The only thing is that it's now missing its first 2 terms. So again, instead of starting at 0, I'm going to start it at 2. So we can rewrite this as the sum from n equals 2 to infinity of -1 to the n, x to the 2n over 2n factorial.